from basics of RAG and what is RAG and how we can use the RAG system. First of all, if you don't know RAG, RAG full form is Retrieval Augmented Generation. Don't go on the name. I'm just next I'm explaining the all and each thing of RAG system. First of all, why we what is RAG and why where we use RAG for the improve the AI system. Okay, first of all, what was the limitations of LLM? uh, why we are using the RAG, and first to identify that, first we want to look out on what was the limitations of LLM. First, LLM has knowledge cutoff, means LLM did not have real time knowledge. Always they have knowledge cutoff. First, that was the issue. Second, no citation. Third, incorrect data. Sometime LLM has incorrect data. If sometime if trained on wrong data set, then it will got the incorrect data. And fourth one is limited context window. If you don't know about context window means you can, in simpler language, you can consider like as how much text LLM will proceed, or you can say process. Okay, how much text LLM will process or take in their mind or for the next process, you can consider in that simple language. LLM has limited context language. LLM did not get, we cannot upload 800 pages 100 pages PDF to understand. The LLM can not read that whole books at once, and LLM did not get remember all the whole book. In that case, our RAG is come and they will solve the issue of context window, or you can say it will be the most efficient make our system. Okay, first of all, uh, just introducing some what was the RAG system, how it process, how we can store that. First, there are the data we can store in vector database. If you know, there are the databases like SQL, uh, non-SQL databases. There is another type of database like vector database. If you know vector, there are the three-dimensional database. It has three dimensions. Vector database. Okay, these are the most important thing in RAG. Okay, the first thing was data. That there are the multiple types of data we can store in our vector database. uh, First of all, just understand what was the vector embedding and index. In this video I'm not giving you the jargons of word. I am keep it simpler. If anyone new person, they will easily understand what is RAG and how it will implement. First of all, we can just look out on vector database. I can tell that what was vector database. Okay, you can see there is the data was stored in three dimension or 3D space. Okay, vector database is used the similarity search, or it will store the data according to the similar things. I'm not going to provide any jargon right now. Just you can say it will store the data in 3D space using which was the most similar or semantic thing they are store at equal or low distance, and something are not related to anything. I'm just making it completing. If some suppose there was a black. Okay, just taking example of colors, suppose there was a black color, their hex code was FFF, and the another shade of black was gray, their code is FFF98 something, take it. And they will, suppose we want to store on the vector database, they will store at the closest or their distance in between, they are the less. And suppose we want to store the white color in our 3D space, and database, it will be the directly opposite position of the blank. That's it. In the similar way, we can store the all our data in 3D space. If you think, if you have a question like why we do that, okay, it's a simple answer. When we store or segregate our data, what it will do, suppose okay, just when user asks query to our database or send natural language query, then it will run a cosine, okay, similarity function. It, suppose you are asking about black color, then it will return related about all the black colors like gray color. If you have, they will return like top n. If you suppose given that I want top n results, okay, if you add black color, then it will give you three result or four result if you want. Then like shades of black that are the nearest of black, it will work on a similarity search. Okay, that's was it. User sends a query, it will retrieve answer, and on that answers LLM can give that. Okay, just if you understand easily what was the thing, we are sending the query and index or vector db retrieve the similar answers, or that similar chunks, that you can say chunks or small part that are saved in our db. How it works actually, it will that chunks are stored in number form. That will be the thing. Okay, just right now you have an idea about how we retrieve our database from vectordb. Right now let's understand how we can. I'm just not give in that detail, just give the simple understanding of how you can store your normal data into vectordb or similarity due to similarity search. Okay, first thing, you want to prepare your data set, whatever structure or unstructured data. Then you want to divide that in the chunks. Like suppose if you have a 100 lines paragraph, okay, first of all you want to divide that paragraph into 200 characters of each section. Okay, then first that was the thing. After that, after chunking, that you want to select the embedding model that can help you to embed that chunks into a vector db. I know I'm just getting too simpler because I'm not include any jargons, and there are the 3 4 steps that you want to for the chunking, and there are the multiple steps. That's the process of how you can store the data, any text data in the vector database. Okay, if you have a question, write that how it will help our LLM to improve their answers. Okay, let me explain. First, suppose you ask the question to LLM, what was rank. Okay, I'm asking the LLM what was the rank. Suppose LLM not have the questions and it not have a answer. Sorry, suppose LLM not have a answer about uh, what was the rank system. In that case, LLM can be hallucinate. If you don't know hallucinate, if LLM did not have an answer about rank system, it will try to generate any answer from their side. Instead of that, if we have attach our rack system to LLM, then LLM can send the query to our database, that in our vector database. Then vector database give 3 4 result that your similar query about track whatever you question ask about that. After that, suppose there are the top 4 chunks, the four part will be written, and that 4 part of data we are passing to the LLM, and on that databases LLM can give us answer. That's the simple process about drag. I'm not in right now, I'm not introducing any jargons because it will be the long process, or it will be the